Today we will discuss trigonometric identities and ratios part 6. F. Summation of trigonometric series. Sum of sines or cosines of angles. A. Sin alpha plus sin alpha plus beta plus sin alpha plus 2 beta plus sin alpha plus n minus 1 beta is equals to sin n beta by 2 upon sin beta by 2 into sin alpha plus n minus 1 by 2 beta. B. Cos alpha plus cos alpha plus beta plus cos alpha plus 2 beta plus this plus cos alpha plus n minus 1 beta is equals to sin n beta by 2 upon sin beta by 2 into cos alpha plus n minus 1 by 2 beta. We have to keep these formulas in our mind as they both are used in different trigonometric summation problems. Example number 1. Find the sum cos pi upon 2n plus 1 plus cos 3 pi upon 2n plus 1 plus cos 5 pi upon 2n plus 1 plus dash n terms. Solution. Let theta is equals to pi upon 2n plus 1. Therefore, we have to find the sum is equals to cos theta plus cos 3 theta plus cos 5 theta plus cos 2n minus 1. Therefore, we multiplied 2 sin theta to both the sides. Therefore, it became 2 sin theta into s is equals to 2 sin theta into cos theta plus cos 3 theta plus cos 5 theta plus dash plus cos 2n minus 1 theta. Therefore, first term, that is 2 sin theta cos theta is equals to sin 2 theta minus 0. T2, which is 2 sin theta cos 3 theta, can be written as sin 4 theta minus sin 2 theta. T3, which is 2 sin theta cos 5 theta, can be written as sin 6 theta minus sin 4 theta, and so on. Therefore, Tn is sin 2n theta minus sin 2n minus 1 theta. They are cutting alternately, sin 2 theta to sin 2 theta, sin 4 theta to sin 4 theta, sin 6 theta to sin 6 theta. Therefore, in last, minus sin 2n minus 1 theta will be cut. This became 2 sin theta into s is equals to sin 2n theta. Therefore, s is equals to sin 2n pi upon 2n plus 1 upon 2 sin pi upon 2n plus 1. But these sin 2n pi upon 2n plus 1 and sin pi 2n plus 1 is equal. Therefore, they both are cut. Therefore, s is equals to 1 by 2. S is equals to 1 by 2 answer. Example number given. Sigma n is equals to 1 to n is equals to 35 sin 5k is equals to 10 m by n. Angles m and n are in degrees and m by n is less than 90. Find m by n. Solution. As it is given, as is equals to sin 5 plus sin 10 plus sin 15 plus sin 170 plus sin 175. We have multiplied 2 sine 5 by 2 to both the sides, therefore it became 2 sine 5 by 2 into s is equals to 2 sine 5 by 2 into sine 5 plus sine 10 plus sine 170 plus sine 175. Therefore, first term, that is 2 sine 5 by 2 sine 5 is equals to cos 5 by 2 minus cos 15 by 2. We have used the formula cos c minus cos d is equals to minus 2 sine c plus d by 2 sine c minus d by 2. Therefore, T2 became similarly cos 15 by 2 minus cos 25 by 2. Similarly, this goes up to T35, which is equals to cos 345 upon 2 minus cos 355 upon 2. Therefore, they are cutting alternately cos 15 by 2 to cos 15 by 2, cos 25 by 2 to cos 25 by 2 in the T3 term, and hence up to cos 355 by 2. Therefore, when we add these terms, 2 sine 5 by 2 into s is equals to cos 5 by 2 minus cos 355 by 2 after simplifying. Therefore, 2 sine 5 by 2 into s is equals to 2 sine 180 by 2 sine 175 by 2. We have again used the formula cos c minus cos d is equals to minus 2 sine c plus d by 2 sine c minus d by 2. Therefore, it became 2 into 1 into sine 175 by 2. Therefore, s is equals to 2 sine 175 by 2 upon 2 sine 5 by 2. 2 to 2 cut, which is equals to sine 175 by 2 upon cos 90 minus 5 by 2, which is equals to sine 175 by 2 upon cos 175 by 2, which is equals to tan 175 by 2, which is equals to tan m by n. Therefore, m by n is equal to 175 by 2. Answer. Example number 3. Find the sum cot 2x into cot 3x plus cot 3x into cot 4x plus cot 4x into cot 5x plus up to n terms. Cot n plus 1 of x into cot n plus 2x. Therefore, according to the problem, we know that cot x is equals to cot n plus 2 into x minus n plus 1 into x. Therefore, cot x can be written as from the cot a minus b formula cot n plus 2 x into cot n plus 1 x plus 1 upon cot n plus 1 x minus cot n plus 2 x. Therefore, cot x into cot n plus 1 into x minus cot n plus 2 into x is equals to cot n plus 2 into x into cot n plus 1 x plus 1. Therefore, cot n plus 2 x into cot n plus 1 x is equals to cot x into cot n plus 1 x minus cot n plus 2 x minus 1. We have taken 1 to the left hand side. Now put n is equals to 1 comma 2 comma 3 up to n, and after adding we get the sum is equals to cot x cot 2x minus cot n plus 2x minus n by 2. Answer. Example number 4. Evaluate sigma n is equals to 1 up to infinity tan theta by 2 raised to the power of n upon 2 raised to the power of n minus 1 cos theta upon 2 raised to the power of n minus 1. According to the problem, as we know, first term will be tan theta by 2 upon cos theta, which is equals to sin theta by 2 upon cos theta by 2 cos theta. We have multiplied sin theta by 2 in numerator and denominator, therefore it became 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2 cos theta. Therefore T1 is equals to 1 minus upon sin theta cos theta, which is equals to 2 1 minus cos theta upon sin 2 theta, which is equals to 2 upon sin 2 theta minus 1 upon sin theta. Similarly, T2 is equals to 1 upon sin theta minus 1 upon 2 sin theta by 2. Similarly, T3 will be equals to 1 upon 2 sin theta by 2 minus 1 upon 2 square sin theta by 2 square. Hence, nth term will be 1 upon 2 raised to the power of n minus 2 sin theta upon 2 raised to the power of n minus 2 minus 1 upon 2 raised to the power of n minus 1 sin theta upon 2 raised to the power of n minus 1. Therefore, minus 1 upon sin theta to 1 upon sin theta cancel, minus 1 upon 2 sin theta by 2 to 1 upon 2 sin theta by 2 cancel, and similarly this will be cancelled from next term, and hence this will also cancel out from its previous term. Therefore, after adding them, we will get 2 upon sin 2 theta minus 1 upon 2 raised to the power of n minus 2 sin theta by 2 raised to the power of n minus 2. As we know that theta upon 2 raised to the power of n minus 2 will be a small quantity, therefore 2 upon sin 2 theta minus 1 upon 2 raised to the power of n minus 2 into theta upon 2 raised to the power of n minus 2, as sin theta by 2 n minus 2, as sin theta upon 2 raised to the power of n minus 2 can be written as theta upon 2 raised to the power of n minus 2. Therefore 2 raised to the power of n minus 2 to raise 2 raised to the power of n minus 2 cancel. Therefore it will become 2 upon sin 2 theta minus 1 upon theta. Answer. Example number 5. Sigma n is equals to 1 to 89 1 upon 1 plus tan n degree whole square. Therefore we have to find this sum. Therefore to find this sum we have to expand this, that is s is equals to 1 upon 1 plus tan 1 degree square plus 1 upon 1 plus tan 2 degree square plus 1 upon 1 plus tan 89 degree square. Now reversing the term, we will write it as 1 upon 1 plus cot 1 degree square plus 1 upon 1 plus cot 2 degree square, as tan 89 degree will be written as cot 1 degree and tan 88 degree will be written as cot 2 degree plus dash 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 plus 1 upon 1 plus cot 88 degree square plus 1 upon 1 plus cot 89 degree square. Adding the above both, we will get 2s is equals to sigma n is equals to 1 to 89 1 upon 1 plus tan n degree square plus 1 upon 1 plus cot n degree square. Therefore 2s will be sigma n is equals to 1 to 89 1 upon 1 plus tan n degree square plus cot n degree will be written as 1 upon tan degree, therefore it will become tan n degree square upon tan n degree square plus 1 after taking LCM as tan n degree. Therefore 2s will become as sigma n is equals to 1 up to 89 1 plus tan n degree square upon 1 plus tan n degree square. Therefore numerator to denominator cancel. Therefore 2s will be written as sigma n is equals to 1 to 89 1, which is equals to 1 plus 1 plus dash plus 1 up to 89 times, which is equals to 89. 2s is equals to 89, s is equals to 44.5. Answer. Now in this very same lecture we will also discuss part 7 of these trigonometric ratios and identities. It is a simple part of this chapter, that is G elimination. In this part we will learn how to eliminate the angles and try to put the answer in the other required form. Example number 1. Eliminate theta, where a sec theta plus b tan theta plus c is equals to 0 and p sec theta plus q tan theta plus r is equals to 0. Solution. It is given that a sec theta plus b tan theta plus c is equals to 0, that is equation number 1, and p sec theta plus q tan theta plus r is equals to 0, equation number 2. Solving 1 and 2 by multiplication method, we will have sec theta upon br minus qc is equals to tan theta upon pc minus ar is equals to 1 upon aq minus pb. Therefore sec theta is equals to br minus qc upon aq minus pb. Tan theta will be pc minus ar upon aq minus pb. As we know, sec square theta minus tan square theta is equals to 1. Therefore put sec theta and tan theta in this very equation. Therefore it became br minus qc upon aq minus pb whole square minus pc minus ar upon aq minus pb whole square is equals to 1. Therefore it became br minus qc whole square minus pc minus ar whole square is equals to aq minus pb whole square. Hence we eliminated theta. Answer. Example number 2. Eliminate theta and phi from the relations. M square tan square theta plus n square tan square phi is equals to 1. M square cos square theta plus n square sin square phi is equals to 1, and m sin theta is equals to n cos phi, and find the relation between m and n. Therefore, in order to be able to take the advantage of the third relation, we will rewrite the second equation again, that is m square 1 minus sin square theta plus n square 1 minus cos square phi is equals to 1. Therefore, m square sin square theta plus n square cos square phi is equals to m square n square minus 1. And from the third relation, that is m sin theta is equals to n cos phi, it became 2n square cos square phi is equals to m square plus n square minus 1. Now as we know, cos square theta is equals to 1 minus sine square theta, which is equals to 1 minus n square by m square cos square phi, from the third relation, which is equals to 1 minus m square plus n square minus 1 upon 2m square, which is equals to m square minus n square plus 1 upon 2m square. Now rewrite the first relation, that is m square 1 minus cos square theta upon cos square theta plus n square 1 minus cos square phi upon cos square phi is equals to 1. Therefore it became m square 1 upon cos square theta minus 1 plus n square 1 upon cos square phi minus 1 is equals to 1. Put the values of cos square theta and cos square phi in the above equation. Therefore it will become 2m raised to the power of 4 upon m square minus n square plus 1 plus 2n raised to the power of 4 upon m square plus n square minus 1 is equals to m square plus n square plus 1 is the required relation between m and n. Answer. Now we will discuss some miscellaneous problems of these trigonometry ratios and identities in the next lecture, and that lecture will be the last lecture of this chapter. That's it. Thank you.